property, like did we write the properties of pure matter, elements and compounds? Elements we have written. Pure matter and compound, did we write the properties? Yes, we have written this. Fine. We have written all of this. Did we discuss the properties of pure matter? Just let me know of that.
Yes, ma'am.
Bachcho? Yes. Amar, Lokhi and Bethel.
Yes, ma'am.
Did we discuss that?
Yes, ma'am.
What are the properties of pure matter? Yes. What are the properties of pure matter, beta? First of all, made of only one kind of particle. Yes. If I think we have not written this, if you have not, please do write it.
Ma'am, I
Today
think
we are going to start solutions, right?
ma'am, I think we did not write this. I didn't write in my note. I just checked it.
Made up of only one kind of particles. What are you saying, Mithun? Could you repeat?
I think we didn't write the pure substances property. I didn't write it.
Yeah, that's what I'm saying. You can write it. Yes. Amar, you were saying something?
And today we are going to start our solutions, right?
Yes, we will start. Just quickly finish this, then we'll start. Now, the particles here could be of both the types: atoms for the case of elements, and it could be molecules for the case of compounds, both of them being pure substances. Yes. Second, are they physically bonded or are they chemically bonded? What kind of bonding is present in pure substances?
Physical.
Chemical. Separated through chemical methods of separation. What else? Do they have variable properties or do they have a fixed set of properties? Fixed set of properties. Why do they have a fixed set of properties? Because obviously fixed composition. And do they have uniformity? Do they have uniformity or they do not have uniformity? What's the point here? For pure matter, can I say that they are uniform? Yes, Sokya. Can I say that the pure substances are uniform in their composition? Yes, Sokya, better respond. All the water molecules will be the same water molecules with the same composition, with the same properties, with the same uniformity. Therefore, pure substances are uniform throughout. Clear? That is the defining point of pure substances. Fine. Quickly do this, then we are moving on to the next topic. Second half of the chapter. Bethel, turn the camera on. Yes, fine.
Finish, ma'am.
Done. Fine.
Wait.
Yeah. Sure. Some examples of pure substances: H2, O2, N2, NaCl, carbon dioxide, H2O, HCl. All these are what? Pure substances. Clear? H2, O2, N2, examples of elements. and NaCl, CO2, H2O, HCl, all of them being the examples of compounds, but all of them are pure substances. Fine. Have you all done this? Should I start the next topic? Fine. Coming on to the next point, that is
Can you scroll up
impure.
for the last line?
Beta
I'm setting.
quickly.
I was setting a third point.
Okay,
You know.
fine. Quickly. Amar, quickly.
I'm done.
Done. Have you done all the points?
Yes.
Fine, good. Coming to impure matter. See, when we discussed the chemical composition of matter, we said that many atoms combine together, many particles combine together to form the matter. That was very obvious that if the same type of atoms or particles were joining together, it would give you a pure matter. Mithun, are you in the class mentally? Yes. Second point. If the particles joining together are different, that is very clear that the matter would be impure matter. So therefore, first point, impure matter is referred to as a mixture. Is referred to as a mixture. Fine. Now, second point, how you see in the case of pure substances, we learned that either it would be elements or compounds, and what was happening, atoms were joining together to give you elements, and molecules were joining together to give you compounds. Okay. Why and how is mixture formed? Mixture is formed or impure matter is formed when two or more than two with the Bethel keep on writing more than two pure substances are mixed, okay, or combined together in a variable composition. Fine. Mithun, we did discuss yesterday that what kind of bonding takes place in case of mixtures between the components?
Physical.
Physical bonding. Good. If physical bonding has taken place, what will happen? Can they be separated by chemical methods of separation? Mithun.
Yes, ma'am.
They can be separated by chemical methods of separation,
Yes, ma'am.
and they can be separated out by physical methods of separation as well.
What, ma'am?
If the bonding is physical, the nature of bonding is physical, do we need chemical methods of separation for separating the components?
Yes, ma'am.
No. No worries, we'll discuss it in detail. Fine. So all of you written this? All of you have written this?
Yes.
Fine. Now
Yes,
let's
ma'am.
say we have water as one pure substance. Is this a pure substance? Okay. We have glucose. Now you will tell me, can I take glucose as a pure substance or will I take this as an impure matter?
Glucose is I think it's impure matter.
Impure matter. Amar, what is this? Impure or pure? Lokya, impure or pure? Bethel, is glucose impure or pure?
Impure. Impure.
Impure. Okay, fine. Impure. Lokya,
Pure.
yes, pure. Why?
What, ma'am?
Why?
Because it's only made up of glucose molecule.
Glucose molecules. Yes, Bethel. Is it pure or impure? Glucose.
Impure.
Impure. Why? Reason, you are giving some answers, right? You would have some explanation to those points. Explain me those points. That's it. Amar, why do you think it is impure? Mithun, look on the screen and tell me why is glucose, according to you, is it like it's impure matter? Why?
I think glucose is not only made up of like same thing.
Hmm.
Ma'am, now I
Glucose
realized.
is a pure form of matter.
Yeah,
What do we
glucose.
write glucose as? C6H12O6. What is this? Glucose, right? Whenever we are writing, this is the chemical composition of glucose. There are different elements here, but there's a fixed composition of all of those different elements. Therefore, it is a compound and it's a pure substance. Please know this. Okay? Please note. It's a pure substance. Glucose is a pure substance. If we have glucose, we have same particles of glucose being repeated. And those particles are the same type of particles, single type of particles being repeated. That is the molecule of glucose. Is that understood? All of you? Fine. So therefore, if I'm mixing water and glucose, if I'm mixing water and glucose, can I call these as the components of the mixture? Can I call these as the components of the mixture? Fine. Now, there are two ways in which the mixing could take place. See, there are two particles. I'm considering this as the H2O particle, okay? And I'm considering this as the glucose particle. Fine. Is there any, when you mix glucose in water in day-to-day life, what happens? Is there any chemical bonding that takes place between them? Yes or no? Respond. Yes or no?
Yes, ma'am.
Chemical bonding takes place between them? Mithun?
Yes, ma'am.
Okay. Bethel? Amar has left. Yes. Bethel? Acha, tell me one thing. Lokya, tell me. Can we mix H2O and glucose and will chemical bonding take place between them? What's a response? Very dull.
Chemical
Huh?
bonding will not happen.
Chemical bonding will not happen. And why do you think so?
Um,
Mithun, why do you think that chemical bonding will take place, beta? Yes,
Ma'am,
Amar. Just a second, Amar. Yes, yes, Mithun. Go ahead.
I don't have proper answer, but I think
Yes.
it's chemical bonding.
Okay, fine. Amar, what do you think will be the type of bonding here between water and glucose if we mix them? Bethel, beta?
And chemical bonding.
Chemical bonding. Bethel? Yes, beta. Respond, respond. Huh?
chemical.
Chemical. Lokya, all of them are going against you every time. I don't know why, huh? They have some group, WhatsApp group in which they are discussing and you are not a part of that group. Huh? See, always remember one thing. I'll give you one more point and then you all will answer this question. Okay. Tell me when you are, Amar, listen very carefully, all four of you. When we are mixing water and glucose, can we have a variable amount of both the components? Can we change the amount of both the components and we will get the same glucose water? Yes or no? Ammar, you say that you can also mix half teaspoon of this glucose in 1 glass of water, and you can also mix 2 spoons of glucose in
Ma'am,
the same
wait.
1 glass of water.
So glucoses are sugar, right?
Yeah, glucose is sugar. We have discussed
So,
this yesterday. That's what I was asking you again, huh? No
so
worry.
sugar and water will be like pure substance, right?
But they are pure substances. That's what we are saying, huh? We have already
So,
established this fact that these two components are pure substances. Now,
yes,
what we are
ma'am.
talking about is that when we are mixing them,
Physical
what is
bonding.
happening? Yeah, physical bonding, you said, fine. Bethel, you tell me, can we have a variable composition here? Yes or no? Just say yes or no. Can we change the variable composition? I mean, can we change the composition? Say yes or no, beta.
No.
When you are making any lemonade, fine. When you are making lemonade, you might have extra sweet and I might take a bit less sweet. Is that possible? Yes or no?
Yes,
Could you
ma'am.
repeat because your voice was breaking?
I'm saying when you are making lemonade, you can have a bit extra sweet lemonade, okay? I can have a bit like lower side on the sweetness. Yes or no?
Yes, yes.
Yes, ma'am.
What does that mean? It is variable composition. In case of water molecule, your water will also have two atoms of hydrogen and one atom of oxygen. My water will also have two atoms of hydrogen and one atom of oxygen. Therefore, it is fixed. Therefore, it's a pure substance. And this can have a variable composition. Always remember this. Okay. And whenever variable composition is there, that is because it's not chemical bonding, but rather physical bonding. And whenever physical bonding is there, please listen to this very carefully. Whenever physical bonding is there, that means two different particles are there which have been mixed together. They have not combined to give you another different particle as was the case in compound. Yes. Therefore, what we see here is that we have something like this. Yes. What happened in the case of compounds? We had A plus B, and this was giving you C different, and C became one particle. Yes. Here we have A and B. There's no different particle. We have the mixture here. Are you all getting this point here? Therefore,
Yes, ma'am.
this
Ma'am.
becomes impure matter. And when this becomes impure matter, this will be called as a mixture. Any confusion here?
No, ma'am.
So, ma'am, you are saying that different type of elements combined and they make mixer.
Yes. And when the different type of particles elements combine, okay, there should be enough variable composition and the physical bonding should take place. Therefore, they will exist as two different elements. Yes, Amar? Two different
Yes.
elements. Here we can talk about not only of elements but also of compounds. Yes, we are saying two different pure substances. Please make that clear. Different components. And what are these components? These components, beta, are pure substances. Is it clear? Now write all these points in order and see the definition that we wrote just now. Go through that quickly, very quickly. Then tell me any confusion.
I wrote it, ma'am.
Yeah, go through that very quickly, bachcho. Bethel, beta, just go through that.
Okay, ma'am.
Yeah. Yes, beta.
Yes, ma'am. Done.
Done. Understood, Amar? Understood?
Yes, ma'am. Yes, ma'am.
Yes. Lokya understood? Bethel, Mithun understood?
Yes, ma'am.
Yes or no, beta? Fine. I'll quickly repeat this point once more very clearly. Whenever we have two or more than two different components existing in a matter, okay, two or more than two different components existing together, they are existing in their own capacities, not mixing together to give you one kind of particle. Therefore, we are having two to three different kind of particles in a matter, and that will make the matter as impure matter. Is that fine? And when
Yes,
will
ma'am.
that happen? That will happen when the components of the matter will not bond chemically. Rather, they will bond physically. Rather, they will exist. They will continue to exist as different particles. And when we
Ma'am.
will have different particles, just a second, beta. When we will
Okay.
have different particles, we will have a impure matter. This line is clear. This concept is clear. Yes or no?
Yes, ma'am.
Yes. Amar, please go ahead with your question.
Ma'am, mixers can also be separated, right? By physical.
Mixtures can definitely be separated. Yes, we will learn about it. Fine. But as of now, what is a mixture? What is the concept of a mixture? How is it different from pure substances? That is clear. How is impure matter different from the pure matter? That is clear to all of you. Yes or no? Fine.
Yes, ma'am.
Fine. Quickly give me one example each of you for mixtures. Very quickly.
And can I say first?
Yes, yes, please. Yes, please.
Salt plus water equals to salt water.
Salt plus water. Fine.
Mm,
Okay. always better to write it like this, or rather as the aqueous solution of salt, okay? Because we are saying that we have two different components or three different components, whatever the components we are having. Okay, beta? Fine, good. Yes, Lokya, I want one example from you very quickly.
Sugar plus water.
Salt plus water, sugar plus water, honey plus water, huh? What else? Tang plus water, ruafza plus water, everything in water, huh? Fine, good. What else? One more.
Sand and water.
Sand and water, see? This water is the main culprit.
Ma'am, we can
Good.
also say
Yes, that all of these examples are extremely right. What else could we have
sand
for
plus iron fillings.
sand plus iron filling? Good. Yes, Bethel. Very quickly. Acha, what is tea? That is what to think. Okay, you all will think over it. What is tea? Is that a mixture or is that a pure substance, pure compound? I mean, pure substances, pure matter.
Ma'am, you mean tea?
Yes, tea, T-E-A, chai.
I think it's not a pure substance.
It's
Ma'am,
not
mixer,
a
right?
pure. It's a mixture. Fine. Why do you think so, Bacho? Both of you, Mithun, first you will answer. Why do you think
Ma'am,
so, beta?
because he
Yes.
had like so much materials like salt. I mean, not salt.
Ma'am, tea powder plus milk.
Yeah,
Tea powder plus milk.
like
I think it is milk powder plus tea leaves, huh? Amar,
yeah,
थोड़ा सा
Sorry.
उल्टा हो गया. It is milk powder and tea leaves. It's not tea powder and milk, huh? No worries, that's fine. The recipe has gone a bit on the different side.
Ma'am, we use milk plus tea powder, right?
Okay, fine, fine, fine. I get your point. Bethel, is tea a pure substance or is it impure matter? Amar, I'm sure you must be drinking chai, right? You must be drinking tea.
Yes.
Yes,
No,
good.
sometimes.
Coffee.
Yes.
Sometimes cold drink, huh? You also need to add that. Fine. But my point here is just kidding. Point is that can you explain me why do you think tea is pure matter or why is tea impure matter? Yes, Amar. Mithun gave me his answer. Fine. Amar, bache, give me your answer.
Ma'am, as you said, mixer is two or more substance physically. So tea also contains two or more substance the many substance milk powder, milk or
Mm-hmm.
tea powder.
Mm. But I also see this could also be applied to this. Glucose has carbon, glucose has hydrogen, glucose has oxygen. So then, by this definition, that many substances are there, many different components are there. Glucose could also be a impure matter, right? But I just now told you that glucose is pure matter. Amar and Muthun, both of you gave the same point that since tea has many components, it should be a impure matter, right, Bacho? But by
Yes.
that definition, by that concept, by that reason, glucose should also be impure matter. But that is not the case. Bacho, one very clear point. See, in case of tea, when we are mixing the different components, both of you are saying the right point, but you need to phrase it correctly. When we are mixing different components, the number is not a matter here. We can mix 10 components, we can mix 2 components. That is not the point here. The bonding, the nature of the combination between the components, that is the main point. Okay. And when the nature is different, there could be a chemical bonding, it will be a pure substance, there could be a physical bonding, it will be an impure matter, that is mixture. Secondly, when making tea, you can have a variable composition. It's not that for every 2 ml of milk, you will have to have 1 ml of this and 2 ml of this. Okay, the composition is not fixed. That is clear cut a case of impure matter, right? Is that clear? Yes or no? Fine. Amar, I don't think so that is clear. Any problem, Mita?
No problem.
No.
Clear.
No. Bethel, Lokya, clear. Now, Amar, you must have seen this namkeen packets, right? The dal mood packets.
Yes, ma'am.
What's your favorite? Tell me what is pizza?
Hindi.
Huh? Did you just say Hindi? Fine. What is pizza? Is it
What
pure
is
matter, impure matter?
pizza?
Yep,
impure.
impure. Mithun said impure. Beth Bethel?
No,
Yeah.
I
Yes,
think it's
Mithun.
pure. I think it's pure.
Ethan thinks it's pure, fine. Bethel thinks it's pure. Look here.
Impure.
Impure. Amar?
Ma'am, pizza must be impure substance because it is made up of different substance mixed together physically.
Now Amar has been excluded from the group, huh? Earlier it was just Lokya out of the group. Now Amar has also been excluded out of the group. Bethel and Mithun, bacho. Is the composition fixed in pizza, huh? You will have just 2 slices of tomatoes for every 1 slice of the pizza and things like this? No. Hmm? It's impure matter, simple. Hmm? It's impure matter, yes. Many different components are combining together and they are not combining chemically. But you please understand this point, okay? Fine. Any other confusion here?
No.
So if I ask you to quickly tell me the properties of mixture, what will be the properties of mixture? Although I've written all of this down,
Properties
but
of,
mixture, impure matter.
can I say properties of mixers?
Yeah, please say one point. Yes, say Amar.
Like no chemical bonding,
Mm-hmm.
physical change only,
Physical change,
can be
physical bonding.
heterogeneous or homogeneous.
That's a different point.
Okay.
But that's right, but that's a different point. Yes. See,
Variable
start with the
composition.
basics. Start with the basics.
Ma'am, variable composition.
2 or more than 2 pure substances combined together. That's it. 2 or more than 2 pure substances combined together. Second point, what is the nature of the bonding? What is the nature of the combination? Bethel. What is the nature of the combination between the 2 or more than 2 pure substances and impure matter? What's the kind of bonding there?
Physical composition.
Physical. This is the second point. Third point, what is the kind of the composition? Is it fixed or is it variable?
Variable.
Variable. Very good. Fourth point, look here. Will they have the mixture since they are existing as 2 components? Let's say we mixed A pure substances, B pure substances. Yes, they are existing as this. The properties of the mixture, will they be a result of the properties of the components or will they be completely different properties from the components?
Ma'am, I didn't understand the question.
Fine. Let's say we had some properties of A, we had some properties of B, right? We are mixing them together in this mixture. That's fine.
Yes,
Will
ma'am.
the mixture have the properties as a result of the properties of A and B joined together? Okay, mixture of both the properties of both the components, or will the mixture have completely different properties as we saw in the case of compounds?
It has its own properties.
See, but an important point, property of a mixture, please note this down. Property of mixture is a result of the properties of its constituting units or substances or components. Simple. Therefore, if we are mixing lemon, if we are mixing salt, if we are mixing sugar in water, okay, it's a mixture and it will have the taste of all of the substances which have been mixed together. Yes, bacho.
Yes,
It's
ma'am.
not that it will have a completely different taste. Is that clear to all of you? This point is very
Yes,
important. So we
ma'am.
have discussed 4 points of the mixture, the properties of mixture. I will not repeat them again. If there is any problem here, please ask me right now.
No.
Amar, no problem, ma'am. Just say that, huh? No problem. Any problem, Amar? No, ma'am. Yes, Amar. Any problem? Amar is busy talking to someone.
Yes, ma'am.
Yes. Any problem,
Ma'am,
Amar?
I'm talking to my sibling. My sibling was
Okay.
disturbing me.
Oh my God. Then what did you do? Did you scold him or her, or did you just disturb him or her again?
No, I said don't disturb me.
Okay, fine. What I'm asking to you is that any confusion here? Is it clear to you?
Yes, ma'am, clear.
Any problem? No problem. No problem. Fine. Fine. Should we move ahead to the next point, bacho? Then coming on to mixture. So once we have understood the mixture, okay, we will have further classification of mixture. One will be homogeneous, the other will be heterogeneous. Method, since we discussed this yesterday, can I ask you what do we mean by homo and what do we mean by hetero?
Almost
Ma'am,
like
can I
same
say?
substance.
Yes, same substance.
Heterogeneity.
Beta, we cannot say same substances, okay? Substances is a different term here. You're getting substances being pure matter. Same mixture, I mean same uniformity. Hetero means different. Yeah, fine. Very good. So now, in case of homo and heterogeneous mixtures, we will assume the same point here. We are saying A is a pure substance, B is a pure substance, and they have been mixed together, okay, like this, resulting in a mixture. If the mixture will be homogeneous, what will be the properties? What will be the properties? First of all, even distribution. Okay, even distribution. Okay. Second, uniformity throughout the mixture. But you keep on writing, then we will discuss this in detail. Whereas in case of heterogeneous mixture, it's uneven distribution. No uniformity. Okay. Third, see, the main difference comes from this point. In case of homogeneous mixture, actual dissolving takes place. Are suspended or dispersed. Last point. In case of homogeneous mixture, since there is uniformity all throughout, okay, we cannot really differentiate between the boundaries of the different particles, okay. Of different particles. Different particles visible. Is it clear, bacha? In both the cases, we are having two kind of different particles, okay, two different kinds of particles. The
Yes,
point is
ma'am.
that when it is the homogeneous mixture, they have been mixed properly because of the dissolving. Therefore, we cannot differentiate while they are in the mixture that there are two different kind of particles here. It appears to be same. Fine. First point. Whereas in the case of heterogeneous mixture, the particles are quite differentiable. Any problem here? Any problem?
No.
No. Fine. Coming on to the homogeneous mixtures. First point, homogeneous mixtures are referred to as solutions. Are referred to as solutions. In many places, you will also see that this might be referred to as a true solution, and we will discuss why. Okay. Whenever the question says true solution, it is referring to a homogeneous mixture. Amar, you are mute, beta. If you are saying something, you are mute.
No, ma'am. I was just reading the points.
Okay, fine. Have you all written that down? Should I scroll that up, or is it okay?
Now you can scroll that up.
Yeah,
Just
yeah,
2 points.
yeah, sure. Bethel, you have written that down, beta? Lokya, have you written that down?
What, ma'am?
Have you written this down? Homogeneous, heterogeneous difference?
Yes, ma'am.
Bethel, why did you not attempt the test, beta? You did not attempt the attempted the full chapter test, right? Although the chapter has not been completed, but then also at least should have attempted that.
This chapter?
The second chapter, beta. Recently, in the last week, I think, or something like that. Fine. Try to attempt the test as many number of times as possible. This will just help you with the preparation. Amar, you also. You did not attempt the test, huh?
Yeah, ma'am. The second chapter was not completed in a school. And there was
Not even
some.
in the course. Fine. Fine, I get it. Sure. No worries. And next time when it is there, attempt it. Fine.
Yeah, ma'am.
Mithun, done,
I
beta?
told that when the chapter is completed, I will
Ma'am.
attempt the chapter
Fine.
question.
Good, good. You should do that. Fine. Amar, have you written this down, beta?
Yes, ma'am, wrote.
Fine. Mithun, done? Should I go ahead?
Yes, ma'am.
Coming on to the homogeneous mixture. What is it called as? It is called as a solution. At times, it may also be referred to as a two solution. Rokia, are you okay, beta? Are you not feeling well?
What, ma'am?
Are you not feeling well? Is there any problem?
No, ma'am. I just have cough and cold.
Take care. Okay. So coming on to the next point. Quickly see what happens in a solution. A solution will have two components, that is for sure. We are just taking the simplest case of a solution having two components. Okay. Why is it having two components? Because it's a mixture. Mixture will have two or more than two pure substances. That is for sure. But the point is that in case of homogeneous mixture, the components would be dissolved properly into each other. That is the only difference here. Fine. So solution will have two components, a solute and a solvent. A solute and a solvent. The part or the component of the mixture which is in greater quantity is called as the solvent. Okay. The component of the part or the part of the solution which is in smaller quantity is called as the solute. Could you tell me, Bacho, in case of sugar and water, which one, that is a solution, right? Because that is a mixture and that is a homogeneous mixture. That is a homogeneous mixture. In case of that, Bacho, can you tell me which one is the solvent and which one is the solute?
Salt water, right?
Sorry, beta.
Ma'am, the salt water, right?
Salt water, yes. In the case of salt water, which one is the solute and which one is the solvent?
Salt is the solute and
So very good.
water is the
Salt is the
solvent.
solute. Wonderful, excellent. Solvent is water because clearly water is in a greater quantity in case of the mixture. Very good. Coming on to the next point. See, this is very important. Please know this. When we are referring to solution, okay, since this is matter, it will have some physical state. Either it will be solid, liquid, or gaseous. Okay. Now, since there are two components, which are solute and solvent, the solute can be either solid, liquid, or gaseous. Fine. And the solvent can also be either solid, liquid, or gaseous. Is that clear? And one point, generally the state of the solution, the physical state of the solution is generally determined by the physical state of the solvent. Is it clear, beta? Yes or no? In case of sugar and water or salt of water, sugar and salt, both of them are solids, whereas water is liquid. But what is the physical state of the mixture that we get afterwards? Is that a liquid? Yes, that is a
Yes.
liquid. Fine. Yes. Mithun, understood?
Yes.
Fine. Coming on to the next one. See, based on this, the solute could be solid, liquid, gaseous. The solvent could be solid, liquid, gaseous. So we are going to discuss some of the examples here of a solid solution. Okay. Solid solution, liquid solution, and a gaseous solution. Quickly give me one example of a liquid solution, bacho. Any example? Hmm?
Sugar water.
Huh? Beta, be a bit clear. I'm not able to understand you. Yes.
Sugar and water.
Sugar and water, fine. Sugar and water. Okay. We can also say lemonade, salt and water. Yes, Mithun, you were saying something. You had raised your hand.
Ma'am, I did not raise my hand.
Fine, no worries. So sugar and water is one example of a solution which has the physical state as the liquid state. Clear? Quickly give me one example of a gaseous solution, Mithu.
Yes, yes.
Mithun will answer. Mithun, we discussed this yesterday, bacha.
Hmm.
No worries. Yes. See, bacho, look here. Air is a gaseous solution. And why we will discuss. See, I'll discuss this here. Air, what is air? Bacho, can I say it's a mixture? We always say air is a mixture of different gases. 78% of nitrogen, some 21% of oxygen, yes, 0.03% of carbon dioxide, and rest all other gases. Clear? Now see, this is a pure substance, this is a pure substance, this is a pure substance, water is a pure substance. All of these are pure substances which have been there, which are there in a mixture form. Is that clear? Therefore, it is impure matter or it is a mixture. Clear? But now what type of a mixture it is? It is a homogeneous mixture. In the air, we are not able to differentiate between this is nitrogen, this is oxygen, this is carbon dioxide. Okay. Because the mixture is homogeneous, because the bonding is quite even and uniform. Is that understood by all of you? Fine. Now, why is air called as a gaseous solution?
Because it contains air, I mean gas particles, gaseous
Yes,
particles.
that's right. It contains gaseous particles. Amar, is that right answer?
Yes, ma'am. Right
Okay,
answer.
fine. If we are saying that air is a gaseous solution, okay, we will have a solute and a solvent for air also. Yes.
Yes, ma'am.
And Bethel will tell me which one will be the solute, and Ammar will tell me which one will be the solvent.
In air,
Yes.
solute means more, solvent means
Beta
less.
solute means less. Solute
So
means less. Solvent means more.
solute less means carbon dioxide, and
I
solvent
asked
means
you for solvent. Yes. No worries. Solvent will be? No worries. No worries. Answer.
will be
Solvent.
nitrogen.
Wonderful. Nitrogen will act as a solvent, and solute could be oxygen, carbon dioxide, water, any other gas particle, okay, mixture which is present in the air, that would be the solute. Is that clear to all of you? Fine. Now, one very important point here. Amar will answer me this. Amar, listen to the question carefully. I will not repeat the question. We have always studied that air is a mixture and that contains 78% of nitrogen, 21% of oxygen, 0.03% of carbon dioxide, and etc. All of the other components of the air. We have a fixed composition here. 78% of nitrogen, 21% of oxygen. Since there is a fixed composition here, why are we considering this as a mixture and why not as a pure substance? One very
Ma'am,
important
because
point,
Ma'am,
just a
because
second. Why?
there are uh,
Just, just, just a second. Very important point that I'm trying to make here is that we learned this in pure substances that pure substances have their characteristics because of the fixed composition. Yes, had there been no fixed compositions, the compound would not be a pure substance, right? And whereas in the case of mixture, what is the differentiating factor? Here also two elements are joining together, but they are not joining together in a fixed composition. That is the difference here. So when all these properties of the air are more towards the compounds, they are behaving like the compounds, they are mixing together like the compounds. Why are we calling them as mixtures? Yes, Mithun, please go ahead with your answer.
ma'am, because both the pure substance mix together.
Mhm. Both the pure substances are mixing together, better that also happens at water. In water, I'll write it here. See, hydrogen is a pure substance, oxygen is a pure substance. Both of them mix together and they give you water, right? But the point here is that in case of water, they have a fixed composition. Only two atoms of hydrogen will combine with only one atom of oxygen. Getting that? So
Yes,
then
ma'am.
why do we say that air is a air? First, tell me, do you all agree that air has a fixed composition? Yes or no?
yes, yes.
Yes. Then why are we saying that it's a mixture?
No, 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 no.
Beta, say the answer. Yes, Amar, you want to say something?
Yes, ma'am. Air is
Yes.
not a fixed composition, and
Mm-hmm.
there are several gas like nitrogen,
Mm-hmm.
etc., which make air. So air is a
No
mixer,
worries.
not
But
a
see, my
substance.
point here is that we might have many components here in the air. But for every component, we have a fixed percentage. See, nitrogen is 78%. Oxygen is 21%. Are you getting this? Then why are we saying air is an impure mixture? Look here. Different from the WhatsApp group. Tell me your answer.
88.
Ma'am, you are saying that why air is not a pure substance,
Yes.
impure
Yes.
substance.
I'm saying why is air not a pure substance and why is air pure substance? Even though it has a fixed composition, we can clearly see here. Yes. Because in the beginning, I told you that if the composition is fixed, it will be a pure substance. Yes, Mithun. Do you agree with that statement? If the composition is fixed, it will be a pure substance because the bonding will be chemical, and because of that bonding, it will give the particle a totally different properties. Yes, but that is not the case in mixtures. So why are we saying that air is a mixture, even though the composition is fixed? Yes, Bachcha.
Maybe it will be chemical bonding.
Yeah, sure, sure, sure.
Sorry,
Yeah,
physical bonding.
huh?
Because of physical bonding.
Fine. Physical bonding, but the composition is still fixed. So I'm not even sure is there physical bonding, yes or no.
Yes, ma'am.
Is the
Ma'am,
composition?
air is a mixture because it has multiple components.
Water also has multiple components. Glucose also has multiple components. All of them
Yes,
are pure
physically
substances.
combined.
Sorry, physically.
They're physically combined.
In case of air, are you saying that, Acha?
Yes, ma'am.
How do you know that they are physically combined? Mithun also said the same point. But my question to both of you is that how do you know that they are physically combined? Think and then let me know. Amar will give the answer. Amar, are you playing some game of rotating this? Huh?
No,
Are you
ma'am.
trying to experience different areas of air so that you are able to know whether the composition is fixed or not? Huh?
No, ma'am.
Fine. But be serious. Huh? At least when we are. Bethel will give me the answer. Yes, Bethel.
Yes, ma'am.
And no one has the
Yes.
answer, I think.
Huh? What is the answer to this, Bethel? Why do we say that air is a I mean, why do we say that air is a mixture even though the composition is fixed? Hmm.
Ma'am, I was also having the same answers that
Same answer. Different component? Yes. Look here, bachcho. Amma, turn on the camera. Stop searching for it. See, the point is that both of you were right. There are 2 points because of which air is a mixture and not a pure substance. First of all, there are many components in it, and those components are physically combined to each other and not chemically. That's the right point. That's the first point. Second point is that air does not have a fixed composition. Does not have a fixed composition. I repeat, air does not have a fixed composition. And why? Listen to these points. At times, due to the pollution increasing, the amount of carbon dioxide varies in the air. That is first point. Okay. The second point is that when we go at higher altitudes or at lower altitudes, the amount of oxygen fluctuates. It varies. Yes, as we go higher, as we go on towards the higher altitude, what happens to the oxygen levels? They keep on decreasing.
Yes, ma'am.
Just a second. Yes, so they keep on decreasing. So can we say that the amount that the composition of air is fixed? Yes or no? The amount of water vapor present in the air keeps on varying. If the humidity is high, the amount of water vapor is high. If the humidity is low, the amount of water vapor is low. Yes or no? Do you all agree with those points?
Yes, ma'am.
Therefore, air does not have a fixed composition. Air does not have a fixed composition. The components of air, although are pure substances, but they're not bonded to each other chemically. Because of all of these properties, the air is a mixture. The air is a mixture. Is that clear? And
Yes, ma'am.
secondly, very important point, the properties of air is not the properties of air are not completely different properties from the components properties. Yes, the properties of air are a mixture of the properties of its components, and these are all the points which have defined a mixture. Do you all understand this? Please note this reason down in your notebooks very quickly. I will not repeat this very quickly.
Okay,
If
ma'am.
there's any problem, please ask me. But try to note this down very quickly.
Yes, ma'am.
Yes. Let others write this down. Mithun, is that understood to you? Understood?
Yes, ma'am.
Bethel, understood, beta?
Yes, ma'am.
Lokya?
Yes, ma'am.
Amar?
Yes, ma'am. Ma'am wrote.
So, therefore, air is an example of a gaseous solution. Clear? But see,
Yes.
here the components of air, that is nitrogen, oxygen, carbon dioxide, okay, they are homogeneously mixed. They appear to be same because they have even composition, okay? That is the point. Therefore, it's a mixture, but a homogeneous mixture. And if it is a homogeneous mixture, I am simply referring to it as a solution. But what is the physical state of this solution? It's gaseous. It's gaseous. And why do we need to consider the physical state here? Because see, we have already said that we are studying matter. It is ultimately matter. We are studying the chemical composition of matter, but it is matter. And since it is matter, it will have some physical state. Do you all agree to this question? Therefore, we are saying that the state here is the gaseous state because of the state of the solute and the solvent that has been determined as the gaseous state. Fine. I'm stopping this here today. Just a minute is left for the class to end. Therefore, I'll not continue this. In the next class, we'll start with the solid solutions. And but to please go through this. I'll not revise all of this again because it takes much of the time. Okay.
Yeah,
Go
ma'am.
through this, through the notes and through the NCERT. Very important. Yes, Amar.
Yes, ma'am. I was saying yes, yes.
Okay, fine. So please go through it and obviously try to attempt some questions whenever and wherever possible. If there's any confusion, please do ask me in the next class. You are free to do that. Okay. Any other problem?
No, no.
Hopefully in the next class, you all will be a bit more responsive and bit more active, huh? See,
Yes,
it's
ma'am.
of no use, I'm trying continuously. Whether you tell me the class is not, you people are not able to understand the concept, that's a different thing. I'll try to improve that. But if that is not the case, you all should be responsive. That will actually give me the energy. That will have the momentum of the class going. Otherwise, it's of no use. Fine. If there's any problem in the way it is being taught, then please convey that to me very openly. I have no issues in that. Any problem in that?